Hello again. So, in this problem we have chords AB and CD have the same length. So let's draw two chords AB and C and D. They have the same length. Prove that the arcs AB and CD are the same. So, we want to show that the arc AB is the same as the arc CD, knowing only that AB and CD, the chords, have the same length. So let's draw the center of our circle O, and let's draw some lines, because one easy way to prove things are the same are by drawing triangles. So let's draw the distances to the center of the circle, and all radii have the same length, so we know these lengths have to be the same. So what that means is we have that triangle AOB is the same or is congruent to triangle COD by side-side-side congruence, because we have proven that the sides in both triangles are exactly the same, which means that angle AOB is congruent to angle COD by CPCTC. If they're the same triangle, then the corresponding angles have to be the same. Now this is important because if these two angles are the same, then that implies that the measure of arc AB is the same as measure of arc CD. And if their measures are the same, that means the ratios of these two arcs are the same, which means that the lengths have to be the same as well. So this is basically completing our proof. We know that since those angles in the center are the same, the measures of each arc are the same. And if they have the same measures, then they have to have the same lengths, since they're both on the same circle. They take up an equal proportion of the circle. So, this gives us an important theorem. If two chords of a circle are congruent, then the arcs they subtend or cut off are congruent as well. Conversely, if two arcs of a circle are congruent, then the chords that they subtend themselves are congruent. That's what we did. Chord AB subtends the arc AB. Chord CD subtends the arc CD, and we've shown that if one is congruent, the other one has to be congruent as well. And that completes our proof.